Hello. Today I'm going to do a question from section 14.7, question 31 from the book, which says find the absolute max mean values of the function x squared plus y squared minus 2x on the closed triangular region with vertices 2, 0, 0, 2 and 0, negative 2. As we know, steps to find absolute max means are first, step 1, find the critical points of f inside D. So inside D is important. We might have critical points which are not inside D, and we won't consider those points. Okay, to find critical points, what we do is find first partial derivatives and set them equal to 0. So if x is 2x minus 2, if y is equal to 1, set them equal to 0. These are easy equations. Each one has only one of the variables, so you can solve them easily. So the critical point of function itself is 1, 0. We are going to come back later to this point to check if 1, 0 is inside the region or not. Okay, but then what else? Step 2 says find all critical points of f of the function when restricted on the boundary of D. You have to be careful. I have to not only find critical points, and I have to take endpoints for each piece also, endpoints also here. And then out of this point, those points, I have to find the max and mean, and those are the max, absolute max and absolute mean values of the function. But now we have to see what's the region. Region is, says it's triangular. The vertices are given by, let me draw my axis a bit further there. So I know that one vertex is 2, 0, the other one is 0, 2, and the last one is 0, negative 2. So basically, my triangular region is this thing. To be able to restrict my function on the boundary, I have to figure out what are the equation for each piece. So here I have to do this piece. So here I know that for every point on that piece, x is equal to 0, and y goes from negative 2 to 2. So negative 2 to 2. And if I want to restrict my, let me write this here. If I want to restrict my function on this, so my function, let me call it f1, which is a function of y, is the function, our original function, whose x is plugged in equal to 0, and y varies from negative 2 to 2. And if you plug in x equal to 0, you get 0 this, so y squared. That's restriction of the function on that piece. The second piece is this guy. I have to find what is the equation of this line. The equation of line you can find by just plugging 2 points on the general form of equation ax plus b. And if you do that, you will get y is equal minus x plus 2. So minus x plus 2, and as we can see, x goes from 0 to 2. So x varies from 0 to 2, and y is given on this line. If I restrict my function on this line, I'm going to write it by 2f2 on x. So it means that x's are x, y's, I put this guy here, and it is given by x squared plus minus x plus 2 squared minus 2x. Okay, let's simplify this guy here. So this is 2x squared. I'm opening up this guy, minus 4x minus 6x plus 4. That's restriction of my function on that piece. And the last piece, which is this guy, it is given by y equal, again, do the tricks. But if you do those tricks, you're going to get y equals x minus 2. For example, if you plug in x equal to 0, you get y negative 2. And if you plug in x equal to 2, you get y equal to 0. Then again, x goes from 2 to 0. The restriction of my function on this piece, I'm going to denote it by f3, depends on x, and that's my original function when I plug in x for x and x minus 2 for y, which gives me x squared plus x minus 2 squared minus 2x. And again, simplify that, then this is 2x squared minus 4x minus 6x plus 4. So now I have restriction of equation for my restriction of my function on each piece. And if I want to find the critical points and endpoints, means that find derivative of each part. So derivative of this guy is 2y, set it equal to 0, and that gives us critical point when you restrict on that. But y equal to 0, and I know that already x is equal to 0. So 0, 0 is the critical point of my function when I restrict on that piece. But I have to also add the endpoints. Y is negative 2 or 2, and x says on this piece, I know those are zeros. So I find 3 points here. What this one? So again, do the same steps. Find the derivative. It is 4x minus 6. Set it equal to 0, then x is equal to 3 over 2. If x is equal to 3 over 2, plug in here, and we get y is equal to negative 3 over 2 plus 2 is 1 over 2. So the critical point for this part is this, and I have to put the endpoints, which are 0, 2, or you plug in x0 here, y would be 2, and plug in 2, you get 2, 0. So I found 3 points here, and then the last piece, which is this guy, then find f3 of x, which is equal to 4x minus 6 equals to 0, which gives me x equal to 3 over 2. And if I plug in x equal to 3 over 2, y is going to be negative 1 over 2. So the new points here are x is 3 over 2, y is negative 1 over 2. The critical points, the end points you pick, and you're going to get 2, 0, and 0, negative 2. So we already found the points coming from the second step, these 3, 3, 3, there are some repetitions, but basically those are the points. Now, before I move on, I have to check if the point 1, 0 is inside the region. Point 1, 0 is here. So basically this is a good point. Now I have all my points. Let me erase this part and then so now we are in our last step, step 3. Find max mean of values of the function on the points found in 1 and 2, step 1 and 2. So those points, the point 1, 0 was, okay, do the other color. So list all the points we have found so far. So I have 1, 0, that was a critical point. Then 0, 0, 0, negative 2, 0, 2. Then 3 over 2 and half. 0, 2 is already there, so the next point is 2, 0. I already have this point, I have this point, the last point is 3 over 2 and negative half. Now I have a list of all the points at which the absolute max or absolute mean can happen. So 1, 2, 3, 4, 5, 6, 7. Find the value of the function on all these points. 1, 0. 1, 0 minus 1, it is negative 1. 0, 0 is 0. 0, negative 2, so this is 0, this is 0, this is 4. 0, 2, 0, 0, 4. 3 over 2 is 9 over 4 plus 1 over 4 minus, you multiply this, minus 3, which gives me 8 over 4, which is 4. 8 over 4, which is 2. 2 minus 3 is negative 1. And yes, this guy here, F2 is 0. So 4 squared minus 4, this part is 0, this is 0. And 3 over 2, negative half, it is going to be the same number, 9 over 4 plus half minus 3, which is negative. Okay, sorry, I made a mistake here and here, both of them. So it is 10 over 4 minus 10 over 4 minus 12 over 4, which gives me minus 2 over 4, which is negative half. And the same computation here gives us negative half. Okay? So now we have all these values. Pick the lowest value you see here. Between them, this is absolute mean value of f. Find the maximum of them. So this is the maximum. So this is absolute max value of this guy here minus half. So absolute mean of this function on that region is equal to negative 1, and it happens inside that region at point 1, 0. And absolute max of the absolute max value of function is 4, and it happens in 2 points, 0, 2, and 0, negative 2. Thank you.